Fantastic. Let's have a look at question 1. In question 1, these are some of the lower tariff questions that we'll see, and typically asking you to identify some different concepts. Sometimes it's about computational thinking. In this case, it's asking you to spot the difference between a logical comparison and an arithmetic operator. Now, logical comparisons are comparisons that result in a true and false outcome. Examples of such. If we had things like not equals to, then a test for not equals to, if we said 4 is 4 not equal to 6, we'd say, yes, it's not equal to it, and it would result in a true. So logical comparisons are like that, or this, or greater than or equal to. Would that be a logical comparison? That one there? No. What would that be? Assignment in this case, because it's assigning the value. What if I wanted to do a logical comparison comparing two different values? What would I write down? Double equals would be a logical comparison, returning true if they're the same and false if they're not. So these are all logical comparisons. What sort of things would we see for arithmetic operators? What kind of things would you expect to see? Plus, take away, div, modulo, mod, anything else? Or multiply, etc. Okay, so hopefully that's going to be a fairly straight question for you to answer for that one there. So please go ahead, try and tick the ones you think are right. Salah, what did we make then for this one? Let's go through them. So this operator, what do you make it? Do you make it either a logical? You think it's a logical comparison. Fantastic. Malike, this one here, arithmetic operator or logical comparison? The next one down. Absolutely, I agree with you. Arithmetic operator. Omar, div.
Arithmetic.
Who agrees? Absolutely. Arithmetic operator. Remember, a logical comparison will always return what? True or false. So in this case, it's arithmetic. The greater than symbol. Who's now had an opportunity? Reese, what do you reckon? Logical comparison, we agree with Reese that it's a logical comparison? Absolutely, because it will return a true or false. Fantastic. Okay, on this side, we've basically been given a bunch of different sort of short algorithms, few levels of programming to evaluate. First one is basically making sure you can do a selection statement and then figure out what's going to happen here. Next one is about, I guess, sequence, the order these things are going to be and following the variable as it goes along. This one is, can you access an array? Although, as identified, it asks it in a very kind way, so you can actually kind of misunderstand it, still did it right. And then finally, for this one, it's saying, can you use some string things? Hey, what do you reckon dot length does? How long the string is. Yes? Why don't we all give that a go right now? You've got 2 minutes, go. So question A, quite straightforward, isn't it? We've got a variable here, assign the value 7. Is 7 less than 10? That would be true. Since that's true, we'll print out temp, so therefore it will output what value? 7. Next one here, value is 3. That same variable that's had 3 assigned has had 1 taken away. 3 taken away 1 is 2. But then we've done, what does that symbol mean? Times, so it's going to be 4. Next one here, remember it's an array. Does an array have an index? It certainly does. What is the index of the first value? 0. So it will go 0, 1, 2, 3, 4, and 5. 2, so it says source with his square brackets 2, it's going 0, 1, 2, it would be 6. As identified, it's also going to help you out, as if you counted it from 1, it would all be 6. But yeah, the answer is 6. And then finally, day.length. In Python, that's the equivalent of len day, like that. What is the length of day? Who's not had an opportunity? Blossom, let's go. What do you reckon?
6.
Yes, so we got 1, 2, 3, 4, 5, 6, same. Oh, and it's worth saying as well, isn't it, that string has an index, and that would be 0, 1, 2, 3, 4, 5. But completely agree with you. Answer is 6. Wicked. Okay, next question here. This time we have an array. And as we've just discussed with arrays, that we have an index. So of this, what kind of data type does this array have? What is the data type of this array? It's got these little things on it. Omar, what do these little things mean I'm doing with my hands? Speech marks. Speech marks indicates it's what kind of data type? String. These are all strings. A searching algorithm is used to find a word in the array data. So this is our little algorithm. The algorithm is used to search for a word is shown. So you input a word, stored as a string. We have this. Oh, false, true or false. What kind of data type would that be? Boolean, absolutely. And then you have a for loop. Oh, what is this demonstrating? Sequence, selection, or iteration? Iteration. It's a for loop. And this is count-controlled for loop, so it's going to go around a set number of times. How many times will this for loop go around in total? No, it starts from 0. 8. Yeah? This would be the equivalent in Python of going for I in range 8. So it goes 0 to 7, yeah? And then as it goes around, I is 0. It will say, is data at position I? So that would be this one. Or is that equal to your word? And then if not, if it is, it will go true. If not, well, it doesn't matter anyway. It will always go up. And it will say if true. All right. What do we call this? It starts at the beginning. It searches each of the words in turn as it goes along. What kind of a searching algorithm is that? Well, what are the two searching algorithms? Linear search and binary search. Linear search starts at the first item in the list, sees if it's got a match. If it isn't, if it is a match, it can report that it's found it. If not, it goes to the next one, and it keeps repeating until either one or two things have happened. Either A, it finds the item, or B, you've got to the end of the list and it's not in the list. How does binary search work differently? Yeah, so binary search, it will find the middle item. So we've got 8 items. So the middle would be technically here. You either go middle left or middle right. Let's say we go middle left. And we say, is the item higher or lower? Can I do a binary search on this list? Why can't I do a binary search? Because it's not in order, absolutely, right? Because it's not in order, I can't do a binary search. Which one's more efficient, binary search or linear search? Binary. However, in this case, what would I have to do? First of all, is sort it. Oh, what are the 3 sorting algorithms? Bubble sort, merge sort, insertion sort. Beautiful. So if I wanted to do a binary search, I'd have to sort it first. Right. So the name of the searching algorithm was what, Ibrahim? Thank you, Omar Ibrahim. I completely agree with you. It's linear search. Awesome. Right, let's have a look at the other question. So this one is a bit more in depth, isn't it? This is the first question where it's asking you to actually write some of your own code. So at this time, it's trying to hold your hand a little bit, though. It's saying some words appear in the array more than once. And you see here, this will just identify, does it appear? And if it appears, it will say true. And if it doesn't appear, it will remain false. Now it's saying we're going to refine the algorithm that instead of just saying is it there or not there, it's going to count the number of times a word appears. So for instance, if we put in the word and, it would want to go along, and every time it finds it, it's going to increase some kind of variable that's going to keep track of it as it goes along, okay? So let's think about what we need to do. We need to keep a lot of this. Do we need to use a for loop to step through it? Yeah, absolutely. We'll still need to use the for loop. What new variable are we going to need to keep? Count. Count of how many times. Should we initialize the count inside the for loop or outside the for loop? Count equals 0. If I put it inside the for loop, what's going to happen? It reset every time. So I want my count equals 0 up here. Absolutely, don't I? Right. Do I still need found there? Technically, found's not necessary anymore, right? Because if count was 0, it means you haven't found anything. So count. So you can say word equals input. Count equals 0. A for loop as it goes around. As you find the word, what should you do with count? Count equals count plus 1, or count plus equals 1, however you want to do it. Remember, we're going to try and be consistent and just use Python coding throughout the paper so that when we get to part B, we're totally ready. The only difference is that in part A, if you mess up the syntax, it's no big deal, as long as it's understandable. All right. Want to give it a try? Give it a couple of minutes, give it a go. Okay, guys, hopefully we went okay. I'm just going to start writing out some of the sections. So like I say, we're going to include some of the original bits, like asking for the word, aren't we? What is the new variable we said we were going to add in? Yeah, something to keep count of how many we've got. And I'm going to be very imaginative, and I'm going to use the word count. Now, do you remember when we talk about maintainability of code, what were the things that we wanted for maintainability of code? Meaningful identifiers, so suitable variable names. What else? Sorry? Comments, indentation, and subprograms. Beautiful. What should I initialize count to be? What value? 0, beautiful. And then I'm going to do the for loop just like last time. This is the bit that's going to look a bit different. This time I'm going to say in range instead of I equals 0 to 7 because we're not using the OCR pseudocode. In this, I suppose I got a choice. I either can do the length of the array, so len data, or I could say 8. I guess it don't really make much of a difference. I'm going to say len, so we're going to get the length of what the array is. The array was data, wasn't it? Somebody help me out here. I can't see the other side. It's data, yeah. All right, wicked. There we go. How do I finish off this line, syntax-wise? 2 brackets and a colon. Beautiful. And in terms of writing my code, do I write it here? Or do I... Beautiful. I have to indent, don't I? Because that does scope in Python. What am I going to do different this time? Well, in fact, what am I going to do the same as last time? Yeah, the if statement stays exactly the same. Guys, stating the obvious, but just want to come back to something we talked about earlier. Single equal or double equals? Double equals because it's a logical comparison. And a single equals would be a assignment. What am I making it equal to? Word, whatever they typed in. And at the end of this, what do I need to put in? I might put that in there. That's actually not necessary in Python, but I think that makes it look a bit neater to read. What's going to be done different this time? So last time we just set a Boolean to be true. What are we going to do different this time? I'm going to add what to 1? Count. So count is going to increment. You can either go count equals count plus 1, count plus equals 1. I'm just going to, I guess I'll write out the whole thing. And then, do we need to output? Oh, here we go. Have I done all the points so far? Am I finished? I must output. Do I print here in the if statement? Do I print here? I'm going to do outside the for loop, so if I do it over here, then we're good. This, I'm sure you wouldn't need to do this, but why don't I? What data type is count? Integer. When I'm printing, should I be printing integers? I would have to. What do we call it when we change from one data type to another? Cast. Beautiful. So I want to cast. How do I what do I want to cast it to? I want to cast it to a string. So I'll do str and then in brackets count. So we're casting. We're reading through the next question. We are now looking at sorts. Abdul, 3 sorts. Go. Yeah. What are the 3 sorts? Insertion is one, and it's, in fact, it's the one we're looking at right now. Apart from the ones that's written down right in front of us, what are the other 2 sorts? Merge sort, beautiful, and bubble, beautiful. Insertion sort, merge sort, and bubble sort. All about having basically 2 sections to a list and placing new items in the right place. So on here, which bit of the list looks like it's sorted and which bit is yet to be sorted? So section A is sorted, isn't it? And section B, so we're partway through an insert sort. What's the next item that's going to be needing to be sorted? Or. And that's just to remind you guys, because we did it quite quickly, here's how an insertion sort will work. That or, what it will do is it will go looking back this way to see where it should go. Should it go in replace of when? Well, it's kind of, yeah, I guess, yeah, it's between or and when, isn't it? So it could go back 1, when could swap with it there, I guess, and then it could go in there, and then it would have to keep on going this way to the left until it finds the right spot, and it would go in there. Yes? So explain why the array is shown in 2 sections. What are we going to say? So we can say A is sorted, and B is not sorted. Guess how many marks that gets you? 2 marks. Isn't that easy money, eh? Next part is basically asking you to describe how the algorithm works, which is kind of what I was just talking about just now. You know what I might do with you? I might actually write down literally the mark scheme so you have that to come back to, but it's essentially what we've just discussed. What's the next item we want to compare? We just said, what was the item if or? So we want to compare or with what? The next item on the left. What happens next? So what is that item we're comparing it with? When. So or is what in comparison to when? Yeah, so we could say it's alphabetically lower or smaller than when. So what? What happens next? Well, because it's smaller, it depends how you want to do it. But of course, it doesn't know you don't know at this stage whether the next item is going to be lower as well. And now we know that's the case. So it has to go along to the next item, right? Because it repeats comparison to the next item and then inserts it in the next place. So because you don't know whereabouts it's going to fall between those two. Which is not necessarily true, isn't it? It's lower. I guess you don't know exactly where. Anyway, I suppose the next one could be a repeat as well, couldn't it? Anyway, and then finally, what does it need to do? Inserts it in correct place. So you'd add to this definition for this algorithm. What else is the algorithm ultimately going to do? Is it finished? Yeah, well, what's the next thing it's going to do? Yeah, repeats algorithm, but with it. Yeah, repeats to insert with it. There is the complete definition from the mark scheme, and it's worth having so that when you're in a position where you have to, because it could easily come up where they ask you to describe how an insertion sort works. Now you've got a textbook, 4, 5 bullet point answer. Wicked. One sorting algorithm splits an array into a single items and then combines them into an ordered array. Abdul told us the other two. The other two were bubble sort and merge sort. What is the one that splits the array into a single item and then merges them? There you go, merge sort. Lovely question, I think, coming up. It's all about computational thinking, so things like abstraction, decomposition, algorithmic thinking, input sanitization, validation potentially could come on a question like this, or verification, right? It's asking us to do a bunch of terms. Essentially, you've got a list, a decomposition, you've got a whole list of different terms, and our job is to read through this list and attempt to place it in the right place. So I think what I want to do is I'm going to maybe I'll give you a quick on a few key ones. Abstraction. Abstraction is all about removing unnecessary detail or unnecessary complexity to allow us to focus the important things. Algorithm is about describing a step-by-step series of instructions to be able to achieve a goal or task. Decomposition, having a complex idea, breaking it into smaller ideas to make it solvable. You might actually break them down again until they're individually solvable. I think, if I go through every single one, that's probably not that helpful. I'll give you a moment. Why don't you have a read through and try and put in the things that you think correct. Computational thinking is the process of analyzing problems so they can be solved in a logical way. The process of something breaks down a problem into smaller, more manageable parts. Malike? I completely agree with you. Decomposition. The process of blank removes unnecessary details from the problem so that the main components can be focused on. Emil? Abstraction. What do you reckon? Abstraction it is. Yeah. Removing unnecessary detail or complexity to focus on the main components to solve. Algorithmic something identifies the main steps needed to solve the problem. I think this might throw people because it's not a term we use that often. We say computational thinking. What do we think might be the answer for this one? It is algorithmic thinking. So it's literally the way of imagining solving a problem by breaking it down into the individual steps. It's algorithmic thinking. Oh, and finally, what do we think? Sequence? Agree with you, sequence. So let's just backtrack one moment. Remember that the journey always starts with some kind of human-readable source code. So that could be stuff like Python, if, something or other, else. Or it could be assembly language, but it's still human-readable source code. And it all goes through a journey using translation to become what? Yeah, low-level machine code. Okay, so they all go through a journey. Now, what were the 3 types of translators, the 3 ways you could translate from that human-readable source code to machine code? What were the 3 different types? Anybody remember? Please.
Compiler and interpreter.
So compiler and interpreter are 2 of the big ones. A compiler takes all of your source code and in one go turns it into machine code ready to run. Advantages are, once it's done that, it's ready to go. It can go really quickly. It's actually a most efficient way of doing your code. Also, you won't be able to see the original source code anymore, so it keeps it so you can't actually go and actually look at the original source code, so it can steal your property or look for hacks or whatever. Also, though, once it's compiled to that hardware. So let's say I've got a MacBook in front of me right now, and I compile my code for that MacBook. It's ready to run on this. Can I take that same machine code and put it onto my Windows computer over there and run it? No. It's compiled for that particular platform, so you can't move it from one to another. An interpreter basically stands between the source code and the machine code and translates line by line, and it does it every single time. Every time I want to run it, I don't have this, I have the source code, and I retranslate it every time. Do you think that's faster or slower than compile code? Much slower. What's its advantages? Well, it can reinterpret for different platforms. So web pages are, for instance, always interpreted. Why? Because maybe you look at that web page on a MacBook like this, maybe a Windows PC, maybe on your phone, maybe on whatever device. And therefore, on Chrome or whatever other web browsers are available, you can do look at the source code, right? The reason you can do that is because it's interpreted. Anyway, what was the other type of translator? An assembler. An assembler takes assembly language and turns it into machine code. All right, okay. Describe 2 advantages to the program of using a high-level language instead of a low-level language. Where would we see a low-level language being used? For instance, a washing machine. Do you think in your washing machine you've got like the kind of chip I have in my MacBook here? No. You'd have some very restricted purpose, cheap as you could make it chip that can do a handful of functions. It's not going to have like 20 billion transistors. It's going to have a few thousand, right? It's going to be simple. Why? Do people want to spend an extra 100 quid on their washing machine so they can actually play Doom on it when they're bored? Right? Maybe you do. Okay, fine. Because it's very focused, do you think it's got all the instructions that a computer like this has? It's got a very limited instruction set, so you use low-level programming because you have real control over that hardware. You can make a very focused bit of code that works for that specifically. So with low-level code are things for like hardware, maybe for other things like, like you've got traffic light system, same deal, probably low-level because you have control of the hardware, really access to it. High-level languages, where would you see them? In your mobile phone, every app that's run on your smartphone, how many of the apps in your smartphone do you reckon have been written in a low-level language? Probably none of them. Potentially parts of your operating system to get low-level control over it, but your actual apps that you're running all written in a high-level language. All right, so with all that in mind, what's the advantage, you reckon, of a high-level language?
Much easier to understand.
Easier to program in, easier to understand. So because it uses language closer to English. Let's write that one. Because the language is closer to English. Now, you might look at Python and be like, that doesn't look like English I've seen. But as an example of an assembly language called Little Man Computing, this would be an example how it would look. You'd have something like, let's make it large enough to actually see, LDA for add 13, STA for out, right? Does that look like a fun language to program in, right? But that's what assembly looks like. Essentially, each of these are an individual instruction. It does them one after each other. You have an opcode and an operand. it's not easy to program in, right? And once upon a time, that's how you had to program all hardware. And we've moved to a place now where we have a much easier thing to look at, which is high-level languages. All right, okay. Apart from easy to understand, what else we got? Well, I've got basically 2 answers here. See what you think about them. And I'll just say them, and you tell me which one you think is easy to understand, okay? First one. Programmer provides higher level of abstraction from the underlying processor because it's further away from it. Means that you don't have to deal with things like allocating memory. Now, there's a flip side to that. Low-level languages have much more control of the hardware itself, which means that you can actually have, for things like dishwashers or hardware like that, it's so limited, you have real control of that hardware level with low-level languages. But high-level languages, you don't have to worry about it in terms of deleting hardware. So on Python, as you're writing your software, at what point do you have to say, delete this from RAM? You never have to do that, right? That's something that's done in the background. But once upon a time, those are the sort of things you have to do. I think that's probably the easier one to do. The other one it says is that it's portable. It means it's processor independent. So you can write Python code. I've written Python code on this computer here. I've written Python on a computer over there. Totally different hardware, no problem. Low-level code, assembly code like this, that code is specific to that processor. Let me write up then the thing. In fact, guys, obviously, there's only 2 points you need to make. I made 3. Look at them. Focus on the ones that make most sense to you and keep those down. Let's look quickly at the other side. We've got a compiler or an interpreter or both. Which of them translates high-level code to low-level code? Which one of them does that? Guys, which one does that? Both. Completely agree with you. Which of them provides an executable file ready to run? Which one turns it into executable file and you have that just ready to run every single time? Compiler. Because remember, an interpreter reinterprets every single time, line by line. Oh, and program needs to be translated every time it's run. Which one's that? Interpreter. Beautiful. Guys, what are the 3 logic gates we have to learn about? These are the 3 gates. Which gate is that? It's a NOT gate. A NOT gate takes in an input, say 1, and it gives an output of 0. So it flips the input. What gate is this? OR gate. An OR gate says if either of those are 1, then it will output 1. If they're both 1, what will the output be? 1. And if they're both 0, it will be... So the one special condition that's different to the rest is if they're both 0. What's the one condition with an AND gate where the output will be 1? 1. Otherwise, it will always be 0. Guys, have a go at trying to read the problem. Have a go at doing the question. A computer game uses a controller with 3 inputs, A, B, and C. So the idea is that either A, B, or C, they could be 1 or 0. Right? 3 wires coming in. An action P is carried out, i.e. it's going to be true, if the player presses A with either B or C at the same time. So A always has to be pressed. And if you press either B or C, it will be. So if A is 1, if A is happening, and B is 1, will it work? If A is 0, will it ever work? So what would you use to make sure it always has to be A? Yeah, are we... Guys, to ensure that it always has to be 1, you have to use an AND gate. So an AND gate could go in here, and you can say, whatever has to happen, it always has to be A. Now, what about B or C? Could I do it like this? No. All right, I see your faces. All right. What do I have to use to combine B or C? OR. So we're going to have B or C go into this OR gate. The output's going to go in here. And then technically, that probably should say P, because that was the output. Yeah, I could do it outside the box. Oh, wait, there is P. My P's dropped off. So you connect it to your P. I've lost my P. I'm P-less. On the right-hand side, this truth table, not to be confused with the test table, right, is a way of recording all the values. Now, do you remember I've told you before the best way to do the combinations is you're just counting in binary, right? So imagine that was 1, 2, 4. That's 0, 1, 2, 3. Then that'll be 1, 0, 0, 1, 0, 1. Oh, so it helps you out here. It's quite easy, isn't it? Yeah. Fine. Right. Can we fill out the table, please? Great stuff. Remember, the tip, as always, on the A, B, C inputs is that you're essentially just counting up in binary. So 0, 0, 0. So imagine C was 1, B was 2, A was 4. So that would be 0, 1, 2, 3. Just to make sure you don't miss any combinations, which means that we need to do, for the final one here, that would be 4, 5, 6, and 7 if you're counting in binary. Because sometimes what could happen is you could just be given these combinations you'd have to fill out yourself as a short little tip to make sure it's easy to do. And then we're looking at outcomes. Now, nice way of doing this quite simply is that if we have a AND gate, well, if one of the inputs is 0 on the AND gate, what would the and does it matter what the other input is? So if that's 0 for A, does it matter what the other input is? No. So anywhere where A is 0, guess what the output's going to be? So now, a question like this could easily catch you out. On here, they're asking you to evaluate that Boolean expression and it'd be so easy to do, evaluate this logical circuit here. Luckily, we're paying attention, would never make such a foolish mistake. So B and C, what is the combination of this that will be different is that they'll both have to be 1 for it to be a 1 in here, and then OR, and then not A. So anywhere where A is 1, not 1 would be 0, so that would be 1 or 1. And then anywhere, so anywhere where this is 1, we can end up being there. The places where it will definitely be 0 would be if A is 1, because that would be a 0, and then either B or C is a 0, and it will also be 0. So let's look anywhere where we've got 1. So anywhere of these, it could be a 0. And then we have to look on the other side, B and C. So what would this make? 0 and 0 would make 0 and 1 would be 0 and 1. B and 1. So 0 and 1 would make 0. 1 and 0 would be 0. So you got 0 on this side, 0 on this side. So these three would be. The last one on this one is not A is 0. So we've got 0 or. But B and C, if it's 1 and 1, it will be output 1. So it would be 0 or 1, so it would be 1. And then anywhere here, if you look at it, if it's not A, so not 0, it will be 1. 1 or, and it doesn't matter what the other one's going to be, it will always be 1. Right? Yes? So therefore, we've got 1 for the rest. And luckily, we took the time to make sure we didn't answer the wrong one, like the logical circuit. It'd be so easily done, but luckily it didn't happen to us. Great. So now we're going to be looking at more programming type questions, looking at different data types. Here's an opportunity to do a quick bit of revision. Here's a little tool also that might help you. If you ever think data types, think cribs. That's your data types. What are they? C standing for character. Now, character is a single letter, or it could be a single number potentially, but it's a string basically with a single character in it. R would be real number. A real number is a number with a decimal place. In Python, what do we use instead of real? We use float instead of real. Yep. I is integer. What is integer? Integer is a whole number. B, Boolean. Boolean is something that results in a true or false. And finally, S is string. So a series of alphanumeric characters. A bit confusing, right? Because in Python, string and character, they're synonymous. A character is just a single letter string. In some programming languages, Java, for instance, character is its own separate data type. And on the exam, they want you to know that character is its own data type. Anyway, character is a single letter string. So it could be like, for instance, you use it for your middle initial. It could be like, my middle initial is R. Feel free to guess. Because in TLDR, no, it actually is R. But it could also be 4. You know, like you could hold it in a string, but it could only ever be 1 in length. It can only ever be 1 in length. All right. What is meant by the data type real? What is a real, please? It is a number with a decimal place. Okay, moving on to the next question. The result of the game can be a win, loss, or a draw. The result is stored in a variable with identifier result. State why result cannot be stored using a Boolean data type. Hatra. So yeah, in Boolean, you can have two states, true or false. True could represent win, false could represent loss. Is that sufficient for this problem? No. So what can we use instead? So we can say, because this is, oh, I've gone on to the next question. String could work. You could restore string for win, another string for loss, another string for draw. Could use an integer. 0 could represent, 1 could represent a win, 0 could be a loss, -1 could be a draw, or 2 could be a draw, whatever, right? You could do a character, W for win, L for loss, D for draw. All of those are perfectly acceptable. In fact, maybe I don't need to write all that out. Why don't you guys give that a try now? Okay, next question is going to require us to do a bit of programming, or answer it with programming. A player enters a code at the beginning of the game. The code is 3 characters long, and the code sets the level of the game. The game has 3 levels. A variable level is assigned a value based on the code entered, and we have to write an algorithm. See, this bullet points is a bit of decomposition. We can tackle it bullet point by bullet point. But basically, you ask the user to enter a 3-character code. So, truthfully, if you feel overwhelmed with these bullet points, you can just, in terms of these 5 bullet points, you could just answer the first bullet point as you go along. That is a strategy you could use. In fact, why don't I demonstrate this time around? Ask the user to enter a 3-level character, right, code. So let's do that. So we can have level, since that's the variable that's assigned a code based on a value. Oh no, sorry, level sugar. Level is actually going to be 1, 2, or 3. So I need something else. So I need, like, I don't know, another suitable name for an input. Code. Very good. So I got code. We are answering this question bullet point by bullet point. Ask the user to enter a 3-character code. So the code's going to be storing it. Ask the user. What's the command to ask a user something? Input. It was not necessary for me to put this message in here, but I got a bit of space. Please enter a code. Why not? I'm prompting the person to doing it. Is there something I'm not missing on this line? Equals, right? Because I basically want to assign this to this value code. So they're going to type it in, and then I'm storing it in code, right? Repeat the previous step if the code is not 3 characters long. Well, I've made myself a bit of a boo-boo now, haven't I? Because what am I going to have to do? I said I was going to do it bullet point by bullet point. This is going to make a bit of a point. So I have to repeat. What do I use to repeat? What's the type of construct we use for repeating stuff? Iteration. What's the 2 different strategies? While and for. If it's indefinite, I don't know how many times, what do I use? While. So I'll use while code to find out the length of the code. So how do I find the length of a code? While len, and then in brackets, code. What about it? While it's what? Not equal to what? 3. If it's not equal to 3, then it's going to keep, that will return true. That will return true, and therefore it will keep going around. What am I going to have to put inside here? Code equals that. Now, probably the shortcut way of having to make me save it, doing it more than once. If I say code equals speech marks, then it'll be 0 in length, and then I can put this inside. Luckily, you have the facility available to you guys where you can just copy and paste the code that you've written down, and then you can just put it like that. Yeah, you all have that facility, right? Okay. Oh, and why did I indent it? Because I have to, because it's inside the scope of the while loop. Yes? Anything else I need to add to that? No. I'm going to keep on inputting it. It's going to keep on checking the length. As long as it's not equal to 3, it's going to continue. As soon as it is equal to 3, that will return false, and therefore the while loop finishes. Have I finished? No. What's next? Yeah, I need to check, don't I, what the value is. How many different? I've got like 3 different values. What do I use? What's the programming construct I'm going to use to check these different things? Selection, which is using if statements. You could also use the select and case statement, but we can use if. So if what? If code equals SVA. I may have made some mistakes. What mistakes have I made? I've forgotten a colon. Syntax error. What other errors have I made? No, the indented, it doesn't want to be indented. If it was indented, it'd be inside the while loop. I don't want to happen inside the while loop, do I? Huh? Yeah. Single equals means that I'm assigning the value SVA to code. Am I assigning the value? No, I'm doing a logical comparison to see if it's equal to, and therefore it is double equals. Yes? If it is equal to SVA, what should I do?
So it didn't matter.
If I did indent it?
Yeah, if you did like double equals.
If I didn't do double...
Yeah, if you didn't do double equals.
Yeah, it would, because then you're assigning a value, and you're not doing a logical comparison.
At least I don't keep it, they're like...
So, truthfully, I think it's pretty universal. They want you to do so double equals is logical comparison. But historically, there were languages like Visual Basic where single equals was acceptable because it was context if it's an if statement. I wouldn't take the risk, personally. Section B, you're definitely not getting the mark. Section A, maybe, maybe not. It depends. Yeah. All right, what do I put inside here? Oh, do I write for this? Do I write it directly underneath, or do I indent it? What do I write in there? Salah, you've got it. Go on. What do I write down there? Level 2 equals... Hey, do I put speech marks? Do I put speech marks around the 2? No, because what data type is it? Integer. Beautiful. Can we do the rest? I'm going to use an elif or an if. Which one am I going to use? Elif, right. There we go. And then for the final one, what can I do for the final one? Else. Now, this is truthfully a choice, but it does say assign the value to level 1 if any other character is entered, so that else is super appropriate. If it gave you another code for level 1, potentially you could do else to like catch any other things they put in, like a bit of validation. In this case, though, we can just go else. Guys, anything else I need to add to this? Nope. I think we're good. Okay, guys. This is the final question in section A, typically a bit higher level, and it's asking us to make use of a function. You remember, a function is when you've got a section of code that we've collected together that we can run every time we call it. What's the difference between a procedure and a function? Function returns a value while a procedure does not. Do you remember what a parameter is? It's the values you can send to a function or a procedure. It's the values you send to it. In this case, when a player completes a level, they move to the next level. Once level 3 is completed, the game starts again at level 1. Okay? So every time you complete a level goes up by 1. Once you get to level 3, you go back to the beginning again. What a fun game. Sounds engaging to me. Write a function called next level. That takes the current level as a parameter, works out the integer value of the next level the player moves to, and returns the integer value. All right, so in Python, how are you going to define a function? What's the first thing you're going to write down? D, E, F. What's the next thing I need to write? Yeah, the name of the function, in this case, is next level. Now, in the brackets, that is where you put what? What do we put in these brackets? The parameters. Every parameter separated by a comma. How many parameters is this receiving? Takes the current level as a parameter. How many parameters is that? 1. I'm going to call it level. How imaginative. Which will be a number between 1 and 3. Anything I need to, if I'm keeping syntax, what I need to at the end, I need to put down a colon at the end at this one. Comma if I have additional parameters. So if there's another parameter, it'd be comma and then another one. This, do I write it directly underneath it or do I indent it? Indent it. Works out the integer value of the next level the player moves to. Well, if the level is 1 or 2, what will the level be? If the level is 1, what level will it return? If it's receiving level 1, what level will it return? 2. If it receives level 2, what level will it return? So if it was 1 or 2, it just increases that level by 1 and returns it. Yes? If it's level 3, does it return level 4? No, it returns it. So what's the special case? Which is the one that's different? 3. So if what? If level is what? is equal to what? What's the special case? Which was the one that was different? 3. If it is 3, what do you do? Why am I not putting speech marks around it? Around the 3? Because it's an integer. If it is level 3, what should I return? Return 1. However, if it's not 3, what should I do? What should I return? If it's not 3, what level will it be?
The level above.
Yeah, so return. You can either do else, or you can just do underneath here, return. What am I going to return? Level plus 1. So it's saying in here, if I receive 3, then I return 1. Anything else, aka 1 or 2, return that level plus 1. Now, you could totally do else. I'm lazy. So if that's true, be clear, by the way, as soon as you return, that function ends, and it closes down, you don't do anything else. It will never get to the next line as soon as you get to return line. So if it was level 3, it will terminate there. If it's not, then it will just jump to this line, won't it? And it will just do return level plus 1. But if you did else, and then return level plus 1, that would also be completely fine. Happy? Awesome. Okay, now there's 2 parts to functions, aren't there, really? There's defining the function, and then there's calling it from somewhere else. Now, calling it is no big deal. You do it all the time. Every time you call input or print, you're calling a function that exists. In this case, it's saying, complete the line of code to output the value returned for the function next level. So you're going to call next level, and I'm going to pass it a 3, passed in a parameter. So what is the name of the function I'm calling? Where's next level going to go? Here or here? 1 or 2? 1. I'm going to call next level. How many parameters do I need to send next level? 1. Oops, sugar. And you see here, between these bullet points, is where I'll send parameters. So what do I write down here? Omar, what do I write down here? Send it a 3. Do we put speech marks around the 3? Because it's a... The reason I keep on making the point is if it was a string, you would have to put the speech marks, and if you don't, you're losing a mark. Now, let's just discuss quickly what that does. Salah, thank you so much for your concentration. I'm sure everyone at home is enjoying the fact that you're being asked repeatedly. If your brother ever listens to this in the future, that'd be hilarious, right? Anyway, when we call next level, what is the parameter we're sending it? Yes. 3. And 3 gets passed on here. Level becomes 3. If level is equal to 3, it returns 1. So what will be printed? What will be printed? 1. Absolutely. You might need to... Actually, this thing would work in Python, but you might need to change it, because currently that's what's returned is an integer. If you wanted to print it, you might have to make like Harry Potter and cast it as a string. Okay, people. We're now on section B. Section B is where we have to be syntax accurate. We make any mistakes with the syntax, it's going to cost us marks. SQL is the first one here. SQL standing for Structured Query Language. Every time we do a SQL question, what is the format? Because this is where we're querying. What's the format? 3 words, one under each other. What's the 3 words? No, yeah, but what in what order? Select. And then from. And then where? Now, this case, they're giving you some of them. You might not get any of them. You just have to remember it. Now, here's where it goes. Select. You select the columns. Each column is separated by a what? Comma. The name of each column or each field is separated by a column. From what? From the table. Beautiful. Where? And this is the logical, this is like the if statement bit, isn't it? Except for this time, do you use double equals? No, you use single equals in SQL for doing a comparison. And then you use, if you're joining things together, you use and. All right, people, I want you to give that a try on OCR drone files. This question here. Complete the SQL statement to display drone ID and mileage. Oh, if you wanted to say all of the fields, what would you do? Asterisk as a wild card. From, oh, we've kind of given that away now, haven't we? And then finish out the rest. Okay, you got 2 minutes. Go on, finish out. No, 1 minute. Okay, guys, I'm going here. So for select, Ibrahim, what do we write down for select? Well said. So drone ID, and then the thing to separate it will be a comma. So drone ID and mileage. Flowcharts. Now, recently, we did a whole bunch of lessons on flowcharts. What are the 3 symbols we care about for flowcharts? The diamond represents a decision. Do you remember that is evaluating true or false? It's a bit like an if statement, but you can have, the flow could come off in, 3 directions or 4 directions, although I think you're getting more than that. It's getting a bit silly. Most of them, I think, are just 2. What else we got? Parallelogram. For a parallelogram, I can speak. That's for input, output. We've got 2 more to go. What are the other 2? Rounded rectangle is for terminators or start, stop. And finally, rectangle is for what? Process, to do something, to make a calculation, to store a value, etc. All right. So we've got our start. Being as that is a parallelogram, that means it's a input or an output. In this case, it's an input. It's reading the mileage from drones. It reads the last check from table drones. So it's got these 2 different values. And then to do the if, well, we have to do the thing what I haven't done, which is actually to read this bit here. So take a moment and let's read this. We're talking about mileage and last check, the difference. We've read them here. If the difference is greater than 10,000, so what calculation can we do here to find out if it's greater than 10,000? If mileage take away last check, what about it? If it's great, so maybe I'll put that in brackets so it's all done together. If that's greater than what? Oh, is it inclusive of 10,000? Greater than 10,000. So not greater than, equal to, greater than. Greater than 10,000. Then if that was true, what should we do? Output check. Do I put speech marks? Yeah. If it was false, no check. Now, do you remember we did quite a few questions on these, on flowcharts? And when we did them, some of them were quite tricky. This is the, I'll say again, this is the additional paper they put in to support you guys. Gosh, it looks like they might be nicer to you with flowcharts, but no guarantees. Okay, people. Classic trace table, where we're tracing the changes of the values of the algorithms are going along, basically proving you understand how the algorithm works. We've done a bunch of these as time went over. I'm not saying anything. And we just need to follow this code. A pilot code is automatically generated when a new pilot joins the company. This algorithm generates a code for each pilot. Now, you can see that this is not quite Python, is it? But you can see it's close enough for us to understand it. Yes? So, I mean, that is identical pretty much, isn't it? C equals random 1 to 100. That's not how it looks in Python. But what do you think it's going to do, that line? Generate a random number between 1 and 100. Yep. While, again, that's not quite the same. You have a colon here, but that's so close. And then C equals C times by 10. End while, so that instead of the indentation, end while basically shows you where the while loop stops. And then you've got pilot equals A plus B plus str. What's going on here with the str? It is, but what is it doing? It's casting it as a string. So C is originally an integer, turning it into that, and then print pilot code. All right. Complete the trace table for the given algorithm. So it's saying that what was inputted was H, and then on here, what is inputted is B. What is inputted, 9 was the random number between 1 and 100. And it's just asking you to then complete, what's the next number you need to evaluate? Because line 4, is that going to be true or false? True, right? Is C less than 100? Being it's true, then the next line you have to do would be 05. And what's going to happen on 05? C equals C times by So what's C going to become? I would like to pause this video for a second so you guys can actually attempt some of this yourself, please. So, this is where we left it. C is 90. Do we have to come back and evaluate the loop again? Of course. It's catching. Is that true or false? True. Being as that's true, what's going to happen here? C will become 900. And it happens again on line 5. So on here, we'll say on line 5, this time it's 900. And then do we have to evaluate the while loop again? We do have to evaluate it. Is that true or false? And because it's false, what happens to the while loop? It terminates. What's the next line I'm going to go to? What's the next line I'm going to go to? 7. Beautiful. And then what's going to happen on here? Pilot code is A plus B, so H, K. Is there a space between H and K? No. Is there a space between HK and the 900? Potentially, you could put speech marks here as well, because it is a string, isn't it? And then... Oh, that's true. Yeah, you're right. You know, that's a fair shout. Let's be consistent with what they did. They didn't do it, so we won't do it. Fine. Agreed. What's next line? Am I done, or any other lines to evaluate? 8. What happens on 8? Well, speech marks are for strings, but Linda did point out they did not do for H or K. Well, I personally would have done probably, but fair enough. If they will be consistent with what they did. Yeah. And then for line 8, what do? We just output, so same HK 900, but this time in that box over there. Here we go. Omar, thank you so much for volunteering. What are the for testing? What are the 4 different types of tests?
Normal, boundary.
Beautiful.
The one where you put it higher than it should be. So
Higher than it should be. No. Higher than it should be. So outside the bounds would be considered invalid. And erroneous is when it's what? Wrong data type. So in this context, let's just talk about it quickly. It's looking for values between 0 and 20. What kind of validation do you call that? It's called a range check. It's not necessarily on the syllabus. It's just good to know, right? So that's a range check validation. So greater than or equal to 0 and less than or equal to 20. What would a normal value be?
5.
Yeah, one that sits nicely in between 5, 10, all acceptable answers. Truthfully, any number between sort of like, I would say 1 and 19 would be acceptable. So I can say 10. Why not? There you go. Boundary, just so we know, my definition of boundary is that when it's valid, but right on the edge of being valid. But a lot of the time, they let you have a nicer one here where they actually just say, oh, and that's what they're given here, which is 20. But sometimes if you say 21 and -1, you're also a boundary on that side. But my definition of boundary is that it's numbers which are still valid, but right on the edge of it, which is what they've done here. 20. What is the expected output for 20? True. And then finally, 32. Is that erroneous or is it invalid? I would say invalid. Typically, erroneous would be, if they did this, that's erroneous. Yes, because it's going to flip out because it's a string, not ready to do it. Invalid. Expected outcome, false. Okay, great. So the next question here is all about writing an algorithm that's going to allow us to read some data here or use some data here to be able to answer a question. In this case, we have the scenario of pilots and whether they're fewer than 2 years, 2 to 5 years, or more than 5 years, the pay they receive based on this, and the pay per mile. So in this, so it says, for example, a pilot with 3 years experience who flies 100 miles, so that would be in this bit, will receive a total of £215 made out of 150 times by plus 100 times by 0.65. and we need to create an algorithm to answer that question. We've got already the input for the experience, so we're storing the number of years experience in here as an integer, and we also have the number of miles. Total pay is initialized as 0, and then what we need to do is use a series of selection statements to be able to calculate it. We've got 3 different ones. We've got less than 2, between 2 and 5, inclusive, so this is where we'll have to consider the less than or equal to command, and then finally more than. So we're going to write a if, elif, else statement here using selection. And why don't we first of all talk about catching this one here, fewer than 2. So what are we testing for? Well, the variable we're testing for is for the number of years, and that's going to be stored in this variable here, experience. We're testing to see if it's less than 2 years, and if you read it, it's not less than or equal to, it says less than 2 years. Remember, we have to be syntax accurate, so at the end of one of these statements we put the colon, and then to show scope we have to indent in here, and we're saying originally total pay is equal to 0. Well, if in this case total pay would be, if we go back to the table, 120 plus 0.45 times by, and can you see what variable it will be? So the one we need to times it by will be miles. Okay, great. So that catches 1. The next one we need to check for is this one here. So between 2 and 5 years inclusively. Now what we could do is do an elif miles is greater than or equal to 2 and miles is less than or equal to 5. But remember, we've already said if it's less than 2, it will be this first one, be caught by this first statement. So we can actually just do an elif, and this time for the elif, we can just check to see if experience is less than 5. Now, I've just made a mistake. Can you see what mistake I've made? Because we're saying less than 5, it would exclude the number 5. And if you can read the table, it says 2 years to 5 years inclusive. That means including it. So I need to change it to, can you see what I need to change it to? That's right. Now, I've made a second mistake. Do you see what it is? It's a classic mistake people might make. As soon as you have one of these things where it's less than or equal to or not equal to, the easy thing to remember is that the equal is always on the right-hand side. So we'd have to change this to the equal is always on the right, and then it's the less than on this side. So it would always be, the greater than would be on this side, the not equal to would be on this side. That's how that works. And then we have to do the calculation, same as this one here. Just think what the change will be. So what's the difference going to be? So it's still, is it 120? No, if you look at the table, this time it will be 150. Is there anything else that needs to change? Well, if you look at the table, how much is it pay per mile? It is now not 0.45, it is 0.65. Okay, for this last section here, to catch the last bit, this is more than 5 years. You have a choice. You could say elif experience is greater than 5, but remember, the else statement for this will catch whatever's left. And the only option is, if it was less than 2, it will be this. If it's between 2 and 5, it will be this. So if we just say else, it will catch whatever is left in terms of numbers. And in that case, it will be total pay. Well, have a think what it will look like. So this time, again, it's not 120. You need to have a quick look at your table. Instead of 120, what's it going to say? That's right, it's 180. And then instead of 0.4, what will it be? That's right, it's 0.85. Now, have we actually finished our question? Well, we've calculated total pay based on the number of years of experience. And there's a requirement to now output it, but you can see they've actually supplied us here with print total pay. So that's the answer complete. With this next question, it's simply trying to check that you understand how you supply a function with the values it needs and then make use of it on its return. So this bit on the left, that's just the context that we had before. And let's have a quick read about what's been asked for you in the new part. The programmer decides to make a function to calculate the total pay for the pilot. So this is, they're going to collect together all these instructions together in a function called calculate pay. So you can imagine the last one, the difference would be is it would say def calculate pay, open brackets, and it takes in two values as a parameter. It takes in the experience and miles as parameters. So you wouldn't do an input, now it's taking it in as a parameter. Refine the algorithm to use this function and outpay the pay to the pilot. So this time, we're going to refine this algorithm here. So instead of actually doing the calculation, we're saying we can already do the calculation inside the function. So the function is called calculate pay, which is this one here. It's going to take in the values of experience and miles as two parameters. So you have to do it in the same order they've said. So you put experience here and miles here. They will be sent to calculate pay, and then it will return the value, and then it'll need to be stored. And let's say we store it in total pay just like before. So let's do this. Let's do the parameters. It will send experience, and the next thing you need to send will be the miles. That's going to generate a calculation, and it will return it over here, and it's going to return it in the same variable as last time, total pay. We need to do that because in here they're going to print out that total pay. In fact, if you wanted to, you could write print and put all this inside brackets and print it all in one go. Okay, this question is really testing for something relatively straightforward, but perhaps we haven't got as much experience as we would have liked in terms of using external files. So you imagine you've got a text file. On every single line, you've got bits of data like they've got here, separated by commas. It's called a CSV file. And you've got this on one line, and you could import that as a string, import that as the next string, etc. And really what you're looking for is remembering what is the code to allow you to be able to read and write to a text file. So let's just go through a couple of those right now. So let's start off by the code to read a text file. To read a text file, we'll need to open a file. So that's an identifier for the file we're going to open. The command we need to remember is just open. Then it's going to take two arguments. And this is the same for all of the ones. It's always open, brackets. Then we need the name of the file. In this case, it would be pilots.txt. And you're going to have to do that in speech marks. And then at the end, what you have is you need to set the mode. There are three modes that we care about. We learned about X in the lesson, but that's about creating a file. And I think that's unlikely. I think it's going to be either reading a file, writing to a file, writing and appending to a file. To read from a file, it's actually easy to remember. It's just R. So that's going to open a file. It's going to open a file called pilots.txt, set it to read, and then when we access file, we can then access it to do stuff with it. If we want to read, maybe we want to read the first line on it, we could say line 1 or line equals, we access the file by this one here, file, and then dot read. Open brackets, close brackets. What will that do? That will access this file we've opened called pilots.txt. It will read the first line and put it into line. And if every time we call read, it will just open a new line, open another line, open another line until we're finished. Now, what else? We can also write to a file. And in this case, that's what we want to do. How is it going to be different? Well, it starts off by being identical. So this is exactly the same as we did last time with creating a file that we can hold, open, name of the file. But here, instead of R, we have a choice. We can either put in the value W, and what W do will allow us to write to a file. But writing to a file means that it will overwrite whatever was ever there beforehand. So it will go into the file and just go start from the beginning and just overwrite stuff. The alternative to that is that you can do append. And append will mean that it will write text after the line's there. So let's say you've already got a file like this with these 1, 2, 3, 4. When we do append, it will add it to the bottom here. If you did write, it will overwrite what's there. Careful on which you want to do. So A for append, W for write. And then for both of them, to be able to actually write for the file, we need to do, same as before, we're going to access the file, we're going to go dot, but instead of read, you guessed it, you'll write out write. And then the argument will be, what is it you want to write to this line? So in this case, maybe we're going to write out this code, but I'm going to write down here, just as an example, I could write the word hello. And then what it will do is it will write the word hello at the bottom of the code. So I've opened it in append mode. I've written to the file hello, and it will type it in here. If I put in W, it would overwrite, and it would write hello at the beginning of the code. Last thing we need to learn is we need to be able to actually close the file when we're finished with it. That's straightforward. Again, it's file dot close. And that will mean that the file is closed for us to do editing. That's all we need to learn for now. So let's answer the question. First thing we need to do is ask the user to input a pilot code and a date of birth. It's not asking to do that as a function, so we'll just write out those two lines. So it will ask you to enter a code, and then we'll also need to ask how to enter a date of birth. Great stuff. Now we can see here what we're going to need to do next is we're going to need to be able to write to a file. So we need to be able to do this data here, file equals open, and it doesn't really make it clear. Let's have a little read about that, whether we need to append or write. Let's say append, shall we? Because it's not super clear. We probably don't want to overwrite if we don't have to. So let's open it in append mode. It's always going to be file, well, whatever you want to do identifying. File makes sense to identify the name of the file. And then it's always open, and then we need the name of the text file. In this case, it's pilots.txt. And the second argument we'll need to give is what mode, and we're going to set it for append mode. You could also do, I think realistically, if you put W for write and it overwrit, it didn't make it clear, or overwrote, I apologize. It doesn't really make it clear which one it wants to do, but I'm going to say append so we don't overwrite it. Now we've got it open, we'll need to then write to the file. So it's going to be file dot, you remember, write dot write. And then we're writing the line. Well, the order is it wants to have the code and then the date of birth with a comma between it. So, and these are both going to be, if you look at here, we've inputted them, they'll both be held as strings, so that's fine as well. So we can say code. I'm going to then add the comma. And then I'm going to add DOB, the date of birth. Now that I've written it, what's the last thing I need to do? That's right, I'll need to make sure I close the file, and that actually will be a mark. So if you don't do that, you'll lose one out here. Dot close. So let's go through this. Where do the marks come from? We've got a mark for doing the input. We've got a mark for opening the file. We got a mark for writing the data to the text file, and then finally a mark for closing it. So 1, 2, 3, 4. So this is your classic end of paper question, testing your ability to write a more sophisticated algorithm using two-dimensional arrays and a function. Remember, with these kind of questions, it's not going to be that you get 0 marks or full marks. Every single time you answer part of the question, you get a mark. And let's get started with doing that. It says a pilot, so we're continuing with the same scenario, is allowed to fly a maximum of 9 hours per day. The pilot code and the hours flown for each flight in one day are stored in a 2D array of strings. So all of this is held as strings with the identifier journeys. So we've got this two-dimensional array. codes, hours flown. The value of journey, so this is helping you out, figure out, okay, which of the arguments is going to be the rows, which is the columns. You can see 1 is 3.5, so that's one's there. The first argument is the row number. The second argument is the column. So if I wanted to get JP67, that would be journeys to 0. Create a function pilot valid, so I have to declare that. Takes in the pilot code as a parameter, so a single parameter. Then it's going to go through the journeys, this one here. And then as it goes through, it's going to look for everywhere where it finds that code, and it's going to need to add these numbers. Now, these should be integers, but you see they're strings. So if we just add these numbers together, these strings together, it's going to concatenate. And we do not want that. So we're going to have to cast these strings to integers to allow us to do the actual calculation. Otherwise, it's not going to work. And then finally, checks if it's over 9 or if it's 9 or less. And then finally returns that value. So let's get cracking. It's been decomposed for us, so let's just do this first one here, creating a function, taking in a single parameter. But the first thing we're always going to write down for Python is def for defining the function, then the name of the function, which is pilot valid, and we've been told it's going to take in a single argument, which is this code. So I'm out of space here. I'm going to type in p code. That's the code, and I need to make sure I put colon at the end. Okie dokie. So I'm trying to calculate this total. So why don't I declare that as a new variable total and initialize it to 0 at the start. Now I'm going to want to step through this array one at a time and be looking for every time that the code is a match. And if it's a match, add in the number. Allow me to step through the array. I'm going to use a for loop. Now remember, often we then use the length of the array to allow us to go through the for loop. The tricky thing is with the length of this array is, do we mean length in this direction or this direction? So we're going to have to just assume that this is the right size. It's 6 in length. Great. So it's going to step through this array like so, one after each other. And then what am I checking for? I'm going through it. I'm checking for matches. So I'm going to say if to allow me to check for that match. What am I checking for? I'm checking if p code, so the code you've been provided as a parameter, is equal to, and we need to access the array. So the name of the array is journey. And then we need to make sure in the square brackets for this array, we're doing it the right way around. So the first value, you see here, it's the row. So 0, 1, 2, 3. So that is where we're going to use this I. So I start off at 0, and then it's going to become 1 and 2 until it gets up to 5. And then are we checking for column 0 or column 1 for the code? Well, you can see we're going to check for column 0. So it's going to check 0, 0, 1, 0, 2, 0, 3, 0 until it gets a match. And every time where it gets a match, it's going to be, it's going to return true for this if statement. If it is true, what should we do? Well, we want to add that to our total, right? So our total started at 0. So it'll be total plus equals. So we want to add up the previous total as well. And then it will be, and this is the issue where you could get caught out. If we did journeys I, 1, it will get the number. But remember, that's a string. So we want to cast that as a float. So we'll do float, open brackets, journeys. We'll do I, because we want to do it at the level we got to. So whether it was true. So let's say it was true when I was 3, then this would be still 3. And then the second argument isn't going to be 0 now. We want to do the next column, which is 1. Right? And that's going to add up our total as we go along. Great. Once we get to this point, we've now got a total that's going to say the number of times it matches. Okay, and we need to now return valid if the pilot has flown 9 hours or fewer, or warning if the pilot has flown more than 9 hours. So after this for, we need to check using an if statement. Don't do it inside the for loop, otherwise it will check it every time. We want to check at the end of the for loop if total is 9 hours or fewer, so less than or equal to 9. If it's less than or equal to 9, we can return returns valid. Now, alternatively, we could have done this as a variable and set it to valid and then return it at the end. But you can also just do it here, because what it will mean, as soon as you say return valid, then the actual code, the subroutine will just end at this point, or the subprogram will end at this point. If it's not, so else, if it isn't that, then you return, aka it's more than 9, you have to return the other thing, which is warning. All right, great stuff. Actually, that's taken up less space than I expected. In fact, I think that's the end of the paper. So hopefully this has been helpful for you, and I'll be looking to do the 2023, both papers, paper 1 and 2, in the run-up to the exam. So see you in the next one.